Everyone talks about recycling, but at the end of the day, there will always be a lot of waste that can just not be recycled.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.
We aim for a future without waste, yet we live in a present full of waste. What are we going to do about that? In many countries, waste is just landfilled. In Germany, it is incinerated. While incineration is doing the dirty job of legislators, companies, and consumers failing to keep their resources in the loop, little is known about incineration. This series is about to change that. Welcome to Incineration in the Circular Economy. This series is sponsored by NEEW Ventures and produced in partnership with EEW, Germany's largest waste-to-energy operator. NEEW Ventures sits at the forefront of innovation, building ventures, improving processes, scouting innovations, with the aim not to waste the waste. I've been working for NEEW Ventures for about 1.5 years, and I want to take you on a tour through waste incineration. We kick off this series with a visit at an incineration plant. Afterwards, we discuss the energy transformation, the sustainable perspective of waste versus landfill, venture potential, carbon capture, and many not so obvious insights in our waste system. In this very first episode here, I met one of the two managing directors of NEEW Ventures, Philipp Böhm. Philipp and I met in Premnitz, a small town about 1 hour west of Berlin. Philipp takes us on a tour through the waste incineration process. Let's start. Philipp, we're here in Premnitz, and you personally, you have a background in product design and design management, and now we're looking at a waste incineration stand, two really opposite sides of the circular journey. How did that happen for you?
Excellent question. Thanks for asking, Patrick. Funny enough, you might think those are two opposite sides of the journey. For me, it's more sort of 2 points on the circle. So yeah, I have a background in product design. Used to work in that space. Also built a lot of different products, physical products, digital products. And at some point realized that all the stuff around us, so all the things we see, all the things, this vest, this helmet, the fence, this whole plant behind us, will eventually turn into waste, and waste that needs to be dealt with. And that was a realization coming out of product design and doing some more strategic work, that somehow I want to be part of actually closing that loop. So I started originally working as a consultant for EEW, working with them on understanding how circular economy is going to change EEW's business model. And then eventually actually joined the company and as part of the NEEW Ventures leadership team.
Okay, so you already mentioned EEW. Tell us a bit more about EEW.
EEW is Germany's largest waste incineration company. They have about 19 plants doing municipal solid waste, so the things that you and I throw into the black bin, and also sewage sludge, so the things that we dump into the toilet. Both of those need to be treated. In total, EW treats about 5 million tons of waste. That's about 1/5 of the overall waste that we produce in Germany. And we all need to remember, sort of, we as the people in this country produce the waste at the end of the day. And then there's only so many things you can do with it. So reuse is great, avoidance is even better. Everyone talks about recycling, but at the end of the day, there will always be a lot of waste that can just not be recycled, and that we made and put out there in this world. And we can then decide as a society, do you want to put that on landfill and just leave it sit there and produce methane and pollute the environment, or put it into waste to energy plants, which at least extract the energy that's still present in the material, and also just compact it and sanitize it by removing a lot of the toxins. So what EW does is it accepts the waste. We do see a lot of trucks coming in here at the scale, and we'll see the process later on. But at the end of the day, what it comes down to is taking the waste and putting it through a safe incineration process to extract the energy out of it.
And it's great to get an initial overview for everyone who's listening right now. We will have some more deep dives on the aspects Philipp already mentioned. So like, what about the waste incineration versus landfill? What about emissions and all that? So stay tuned for the next episodes. So before we dive into the details, one final thing, since we're looking, and especially you're looking at Premnitz and the topic from an innovation perspective, from NEEW Ventures perspective. So tell us a bit more about NEEW Ventures.
So NEEW Ventures was founded about 5 years ago within EEW as a business unit with the clear goal to build new businesses, which is always a little bit counterintuitive or not so straightforward for people who are not fully aware of the startup ecosystem. So for EEW, the realization was that circular economy is significantly changing the underlying business model of waste to energy. And at the same time, with digitalization and now these days AI, there's a lot of disruption in the processes on how plants like these are run. And out of that realization, we did start NEEW Ventures to look at business models that might actually disrupt the core of what we're doing here, or change it through innovation. The initial goal was that we spin out about one venture, so one startup, one new company per year. For that, we have employees in our team that start with a clear idea that they want to be business owners and start a new business and revolutionize part of the waste industry. And then go out there, look for a problem, look for an opportunity. One example there is waste here that we'll talk about a little bit more along this journey. The core idea with waste here is that when we look at these trucks, they're all closed. We do have some basic information about them, but at the end of the day, we don't know what is in these trucks when we put them in the bunker and then when we put that material into the furnace. And that causes a lot of issues in the incineration process. And with waste here, we want to make sure that we understand what waste we're delivering to the plant and how to best use it.
But Philipp, I'm super impressed, as you said, EEW is handling about 1/5 of the waste in Germany. And now we're here in Premnitz. What is it about Premnitz? What's the size? What's happening here?
Sure. So Premnitz is one of EW's plants, one of the few ones that actually uses something called RDF. So that's refuse-derived fuel for those who need to know, which basically at the end of the day means it's pre-treated waste. So it doesn't come straight out of the black bin that you have at home or from commercial producers of waste, but is being pre-treated, sorted, partially shredded, and then goes into this plant to be processed. The plant can accept about roughly 300,000 tons of waste per year. And out of that produces 3 different kinds of energy, because also that changes from plant to plant. So Premnitz is in the lucky spot to have a connection to the electricity network, to have a little bit of an industrial park around here that can take off some of the heat in form of steam. And then they actually do have a heat pipeline connection for district heat. And there it's not quite 1/3, 1/3, 1/3, but I think it's roughly 140,000 megawatt hours of electricity, and about the same in district heat, and then about 100,000 megawatt hours in steam for industrial processes around here. Just roughly because I think it's great numbers, but hard to relate to. So this electricity can power about 40,000 homes for a year.
Yeah, and just to emphasize on what you just mentioned, so we're in an industrial park, and but connecting to the overall circular economy, there's just like a plastics recycling company next door, so that is probably using parts of the energy.
Exactly. Premnitz is part of an old industrial complex, was already around during GDR times. Originally, they were manufacturing plastic fiber and plastic components here, and then it's gone through a couple of iterations. So when we go through the plant later on, we'll see that there is a decent amount of history here with like an old part of the plant and then the new part that we can see in the background.
Yeah, wonderful. And here again, we will have the co-founder of Waste here, Benedict, as part of the series. So we will dive deeper into that one. So you already mentioned the trucks entering here. So why are they actually waiting behind you? What's happening there?
Okay, let's dive right into the actual process. So we have a queue of trucks waiting here. We do have the so-called scale or the weighing bridge where the trucks are being weighed. So for all of these trucks, they're registered. We do have specific waste codes. I'm not going to go into too much detail, but every delivery is registered in the system. Now the truck arrives, they basically punch themselves in. Then they get measured to get the weight of the truck and the weight of the waste that is inside. And then they're being assigned to one of the bunker gates that we'll see in a second, where they can unload the truck. So they put all the waste that they have in the backs, usually roughly 20 tons that fit into one of these bigger trucks. They dump that into the bunker and then pass over the scale again on their way out to get the empty weight. And through that, we can measure how much waste has been delivered, because it's kind of unintuitive when you think about it, because most of the time when we think about businesses and selling and buying, there's usually something that you buy, a material, and then you pay money for it. And what we're not doing is, so EW is obviously not paying for the waste, because the waste is waste, but rather is selling capacity for removal of waste. And so at the end of the day, we get the waste into the plant, but we're basically then invoicing to the companies who have produced the waste our capacity to remove it. And again, there will be interesting later on when we talk about CO2 emissions and other kinds of emissions to understand again how that process works.
And is this the waste I at home put into the garbage bin?
So not directly. This is not, so municipal solid waste is part of the waste stream that is being received here, but as we said, it's all pre-treated before it goes into this specific plant. There are many other plants in the EW group where you now would actually see the garbage trucks that you know from your home or your city. They would go straight into these plants and actually empty out. They get to have a speedy ticket and pass right through, so they wouldn't be waiting in line here. They would go straight to the bunker, empty out, and go back on their route. Also because they're slightly smaller, so they actually have a couple more trips that they need to do per day.
Okay. Yeah. And then basically the weighting is happening to make sure that you will determine the difference in terms of weight, and that tells you how much they are offloaded.
Yeah, exactly. I mean, at the end of the day, there is limited capacity to unload at the bunker gate. We'll see that in a second. So over here, they just make sure that there's not too many trucks in the yard. The weighting on the scale has to do with the checking of are the papers in order and measuring the weight.
Okay, then let's move over to the bunker gate. Okay, so we have a truck coming in now. So what are the steps to offload the truck?
You gotta really know how to reverse your truck. Okay, so if a truck arrives at the plant now, we've passed over the weighing bridge. You see the trucks coming in. We have 6 bunker gates. Those gates are closed with doors, and as soon as the truck pulls up, it gets opened up from the crane driver. and then the truck empties out the roughly 20 tons that they have in their back into the bunker. We'll see in a second on the inside there is a big crane that then helps in moving the waste around in the bunker. Why do we even have a bunker? So a plant like this is in operation 24/7, 365 days per year. And these trucks here, they only deliver Monday through Friday. So at the end of the day, you want to have a certain buffer for weekends, for holidays, but also just in case that the plant, for whatever reason, cannot incinerate waste. So one of the two lines might be down or even both. Then we still want to receive waste in the plant. And so there is space for, I think in Premnitz, roughly 9,000 tons of waste. So for about a week of waste that can be stored in the bunker. And also having a bigger bunker volume helps with the mixing of the waste. Because as we said earlier, this waste can be quite different. There's a lot of differences in the properties. They start with the texture, but predominantly interesting is the calorific value. So how much energy is stored in the waste. And then of course, contaminants or other materials that you actually don't want in the waste, where you need to spread them out and mix them thoroughly to even out the quality of the waste. Now, as we see, there's two different trucks, so if whoever is interested, one of them is tipping at the moment. The other one actually is a walking floor, so it just stays that as it is and slowly pushes out the waste in the back, filling up the bunker.
And this here can be an area for innovation, as you introduced NEEW Ventures, which is about building new ventures, and also waste here. So what are elements of innovation that might not be obvious?
Sure. I think one big misconception there, or something that people are just not aware, is that we put the waste into bins, and then yes, here it gets pre-treated, and then it gets to a company that then puts it into trucks, and then at the weighing bridge here they get signed in. But as soon as the trucks empty out their waste into the bunker, it's basically, we still don't know what is actually in that waste, but also we don't know anymore where that waste originally came from, because now it's in the bunker with another 9,000 tons of waste. So one innovation we can see, let's see if we can see it later in the camera. There's cameras mounted out here that actually recognize the license plates of the trucks delivering the waste here. And together with the data from the weighing bridge, we can actually match those trucks to the original producers. And then when we're inside, we'll see cameras that are recording the waste being dropped into the bunker. And there, with the help of waste here, we can do a matching between who was the original producer and what does the waste really look like that gets into the bunker.
Let's follow that journey and look into the bunker. Now the trucks offloaded the waste. What happens to the waste now?
So this is the waste bunker that we talked about on the outside. We have the 6 bunker gates where the trucks can unload into the bunker. There's actually a gap first, where you can see there's a concrete wall in the middle of the bunker separating the actual storage space from the delivery area. The crane driver here right next to me is actually clearing that delivery area into the bunker, and is then trying to get an optimal mix of the delivered waste in the bunker. As we said, holds roughly 9,000 tons, so quite a decent amount of storage space. And as we're receiving RDF over here, there isn't that much of a wide variety, but we were just talking about how, it might get wet because it's being delivered in open trucks or stored somewhere in the open, so it rains onto the waste, or when it gets cold, the structure also changes. And then there's material like down here, they actually put some mattresses with some higher calorific value. So when we see that the waste actually is too wet or has a low calorific value, can mix that in and then come again to an optimal mix for the incineration. The crane moves around, and then up on top over there is actually where the drop chutes are, where we then fill up a funnel that goes onto the grate and into the incineration. The whole idea is that we there's actually under pressure here in the bunker that already avoids stuff like smell or any other contaminant might be airborne to exit the facility. So make sure that it doesn't get into the environment. That's also why we can't smell it, but it actually smells quite little in the overall plant. And then the next step is that in the funnel, the waste also creates a more or less airtight seal. So it closes off the incineration process from inside the bunker so that we never have smoke or anything coming back into the bunker. And we'll see that later on.
And so actually the main task of the crane driver right next to you is basically to clear the area next to the gates, mix it, and then offload the waste into the drop chute.
Yeah, I mean, actually has quite a lot of different jobs there, so to say. So he has to watch the outside, see what trucks are coming in, make sure where they're delivering, but then also have an eye out for potential contaminants that might be in the material. Also have a sense on what the calorific value might be, which is really hard to say. Yes, you get a lot of experience when you work here for a long time, but still it's hard to say, okay, this is the calorific value or the heat potential that we have in the waste. And the job really is to mix that in a way that we get optimal combustion.
And then there's from time to time this conversation about like dangerous goods like batteries or electronic items in the waste. Does it also affect the operations here?
Yeah, so certainly. So a little less so with RDF because you would assume that many of them have been removed already, but even there, what can really disrupt the plant operation is something that either is explosive, so big gas canisters, stuff like that, but even like long metal or wooden beams, metal rods, pipes, big rolls of material. We're just going into asparagus season again, where there's a lot of agricultural foils that are being dumped into the waste. And when these come into the plant, and they can, wrap themselves around machinery or block chutes or get caught somewhere. And that starts here in the bunker and then in the furnace, but also in a machinery called the wet deslagger, where we basically extract all the unburnt material from the furnace. Even there, it can cause issues if you have material that's too large or too bulky. So again, there we talked about the waster solution on the outside. The job there of the software is to actually try to recognize these kind of harmful or potentially harmful objects and then give an information to the crane driver.
So we're in a control room right now. Why do you actually need a control room?
I mean, we talked about it earlier that unlike classic power plants where you have fossil fuel like oil or coal, waste is actually quite a variable material. So there's actually a lot of different parameters that you need to keep under control just because the input is so varied. And then you have all the other controls that you have for regular incineration process. So you can see up there, I don't know if you can see in the image, for example, there's this little zigzag tooth graph that shows the people in the operations room how the pusher plates on the grate are actually moving, because the waste in itself obviously doesn't move forward on its own. So when we saw earlier where the waste goes into the funnel and creates that airtight seal, it actually hits the grate at the bottom and then is slowly being pushed forward into different zones of incineration. So it first dries up a little bit, and it starts to incinerate, then burns fully, and then gets pushed out into the wet deslagger. And there's a lot of different nuance between how much air you actually give into the incineration process versus how fast you move the grate, because that depends on the calorific value that you have available in the waste or present in the waste at the moment. So there's actually where you can see the fire burning. Sure, yeah. And as you can see, also it's not your classic barbecue where everything's ablaze. So it actually goes through these different stages. I mean, what you control here is literally the full process. So from the amount of waste that actually gets dropped into the incineration process. So there's, for example, one key metric is that you always need to be around 850 degrees Celsius in the combustion chamber. to get rid of a lot of the toxins. So that's one thing to control. If we drop below that temperature, then there's always the opportunity to put fossil fuel into the fire to hit that temperature point. Then you go through the whole exchange process, as we talked earlier, where the exhaust gas transfers the heat over to the pipes and then into the steam. And then also the whole energy production is being controlled over here. So the split between how much of the steam goes into the turbine versus goes straight into the process steam for the industrial applications or into district heat network.
Let's check that outside.
So we're now actually more or less as close to the combustion chamber as we can get. The furnace is right behind me. We can take a peek onto the fire in a second over there. I think one thing I forgot to mention earlier when we talked about the waste composition is that the waste that we receive is make up roughly 50% biogenic and 50% fossil-based, which means that half of the waste is actually coming from stuff like bulky waste, so wooden furniture or the bio waste that some people throw into the trash. And only half the waste is fossil-based, analog to using coal or gas. Now in the incineration process, it burns in the level that we're at right now. The heat rises up above our head over there, and then the boiler is a couple of meters, like roughly 10 meters above us. What we can see behind us is the drop chutes, where a lot of the ash that actually falls out of the hot flue gas already is being collected and then transported out into a silo to be collected, and then fly ash and bottom ash are actually being stored in underground facilities for permanent landfilling.
And Philipp, we are literally the only one here in this area right now, of course being guided by our colleague, but can you give us an idea how many people are involved in such an operation?
Yeah, I mean, as I said earlier, the plants run 24/7. So you have at least 3 different shifts working in a facility. But at a minimum for a given shift, for a plant of this size, you can run it with maybe 4 to 6 people. And then you still need additional people to actually do asset management and repairs. But in general, it's amazing how few people you need these days to actually make the plant run.
So Philipp, is all the waste turned into energy?
You wish. So no, obviously not all the waste is turned into energy. It's not pure energy in these materials. The waste is actually, as we said, quite complex in its makeup. And even in a plant like Premnitz, where it's pre-treated, you still have a lot of material in there that either can't be incinerated or can't be incinerated in the process that we run here. So when you think about residues or what is left over from the waste, it's predominantly slag. That's usually about 20% of the waste. Here, when you have pre-treatment, it's a little bit less because more material has been removed beforehand. What we can see in the back there, that's the slag bunker, where all the material that for whatever reason did not burn. So usually it's metals, there is some concrete and sand and other inert material in there. But sometimes also big tree trunks that are just too large to burn in the process. They get dumped in here, and then they receive further treatment. So there's different companies that then pick up the slag, extract metals. There's ferrous and non-ferrous metals in there, so also a decent amount of value still. And then all the rest actually goes into construction material after it's been treated. And then we have the tougher stuff that we see being treated over here. That's the flue gas cleaning system for the plant. So at different points in the process, we're extracting ash. You can think of your own chimney or fireplace at home if you have one. So there's ash left over when you incinerate material. Some of it is being collected along the process as the flue gas travels through the plant. And then we have the final process step where we clean the flue gas to make sure that it's safe to be put into the environment. For that, it's quite a huge installation. Takes up a decent amount of the overall plant is the cleaning. There's chemical scrubbing and mechanical, so filter bags usually included in the process. And there's live monitoring happening on the exhaust gas coming out of the chimney, so that we can be sure that at every moment the plant is actually below the set thresholds that are required by the German and the EU standards.
This is also one of the where you see the big difference in comparison to landfilling, where you obviously don't have such a filtering.
True. I mean, also in Germany, there's still a little bit of amount of material being landfilled because either it can't be incinerated or because it's left over from other processes. And there's very strict controls around, for example, soil pollution in landfilling. But landfills do emit a lot of methane and other gases, and there it's quite hard to actually control that and make sure that you're not creating issues down the line.
So this is actually basically an environmental and health safety instrument to make sure that everything that gets burned won't pollute the air and the environment.
I mean, won't pollute beyond a certain factor. I mean, there's no such thing as completely removing everything, but the EU law and the 17. BImSch, so the German emission control law, impose one of the strictest thresholds or limits on emissions worldwide, and these plants need to adhere to those restrictions. There's a lot of material in the flue gas that needs to be stripped, so there's nitrous oxides and sulfur dioxide and carbon monoxide, all of those, and they're quite successfully stripped in the cleaning process.
Okay. And at the beginning, when we talked about the Slag, you mentioned about 20% is not being able to turn to energy. Is it basically because of the temperature inside, or what's driving?
Yeah,
that?
so it's for most of that material, it's literally that you can't burn it. So there's no energy stored in it. Sure, if you were to crank up the heat much higher, then you might eventually melt metal.
Yeah.
There's also other materials that cause problems for the incineration process because they start to melt and then actually break down the furnace. But predominantly it's material that doesn't burn.
Okay. Waste is full of energy, but what actually happens with this energy?
We get to use it. So the energy is extracted through a pretty straightforward process that in itself then is getting quite complex once you try to actually do it. But the idea is straightforward. So you incinerate the waste on a grate, and then the combustion gas or the heated gas actually rises up and heats up water, or rather steam, in a pipe system. And then that steam gets run through a turbine. And then that turbine actually turns that kinetic energy into electric energy. And we can also bypass the turbine and use some of the steam in the surrounding industrial park. And a good third of it actually goes into the nearby city to heat homes and heat water for the people living there. Now, for the electricity that goes straight into the electric network, we do have one example behind us of how else we can use the electricity, and that is by putting it into storage, because the price for electricity and the need for electricity actually fluctuates throughout the day and throughout the year. And there it's quite important for a plant like this to be able to store some of the energy, because what is interesting is that now with photovoltaic or solar and wind, where we have different peaks of energy availability throughout the day. And up until very recently, waste energy plants were delivering very constant baseload type energy, because unlike coal or an oil furnace, you can't just ramp up and down the energy production in the furnace, but rather you deliver the waste into the bunker, and then you want to have a very constant throughput of waste through the incineration process. and thus deliver a very constant power output also into the network. And only now with storage solutions, we start to become flexible and be part of a modern electricity network.
So I feel like this is also the point where most people are surprised, in the sense that waste to energy is often connected with incineration and kind of you burn it. But of course, this is turned into energy, and is like EW is carving out other energy sources, fossil energy sources, that at least to me wasn't so known before.
Yeah. And also, I think there waste energy is often thrown in the same bucket with other fossil energy producers, or sometimes seen even worse. There's certainly a reputational topic there. At the end of the day, one needs to remember that, and I said before, we as a society, we're producing the waste. And until we come up to a point in time where suddenly there really isn't any waste anymore, and we fundamentally changed the way that we live on this planet, there will always be waste that needs to be incinerated. And thus, for better or worse, it's an energy source that without alternative use. There isn't really much else you can do with the waste that gets incinerated in these plants.
This marked our first episode in this series, Incineration in the Circular Economy. In the next episode, we zoom out and see how a waste-to-energy plant interlinks with the waste and energy system. Until then, let's drive a profitable circular economy. And please don't forget, the most abundant renewable resource is your imagination.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.